All right, we are in a new unit, Unit 4. Holy cow, we're doing something new, something you have not seen before. This is in section 7.2. Really, all of Unit 4 here, we're going to learn some new integration techniques. In 7.2, we are looking at a technique called integration by parts. So this says that if we have the integral of u times dv, that is equal to u times v minus the integral of v du. So we're going to take part of what the integral that's given, and we're going to define some of it as u and some of it as dv. And then we're going to use this property to get u times v minus the integral of v du. And then hopefully this is something that can be integrated by the techniques we've already talked about. All right, so let's take a look at one here. Example 1 asks for the integral of natural log of x over x squared dx. Notice if we try to do this all the ways we've already learned, there's no way to simplify ln of x over x squared. If I tried to make u equal to ln of x, my du would be 1 over x dx, which I have 1 over x, but I have x squared, so I have an extra x on the bottom. I suppose you could try to solve this. X equals e to the u. So you'd have the integral of u over e to the u, and we're no better off than we otherwise would be. So substituting doesn't work. This isn't a property we already know. Nothing that you learned last year will allow you to integrate ln of x over x squared. Instead, we're going to integrate it by parts. So the first thing you need to do is decide what is going to be your u, and then anything else needs to be your dv. So this here's how to choose your u. This is in the order. The closer they are to the top here, whichever one is closer to the top, that's what you're going to choose as your u. So the highest priority is inverse functions. If you have an inverse function, that is going to be your u. The next priority would be logarithmic functions, algebraic functions, trig functions, and finally exponential functions. It's pretty easy to remember because the first letter spell ilate. Ilate will give you the priority to choose u. Again, the closer it is to the top, the more likely it is to be u. So here we have a logarithmic function, natural log, and we have an algebraic function, 1 over x squared. So logarithms take priority over algebraic functions. So we are going to make our u equal to ln of x. Because u is equal to ln of x, anything else in there needs to be dv, which in this case is 1 over x squared dx. And then we're going to use this rule. So it's u times v minus the integral of v du. Notice we need du and we need v. So to get du from u, we're taking the derivative. Du would be equal to 1 over x dx. And to go from dv to v, you need to integrate. The integral of 1 over x squared, add 1 to the exponent, and divide by that same thing. Should give us negative 1 over x plus c. Don't worry about the plus c. So again, to go from u to du, we took the derivative. To go from dv to v, we integrated. And now the rule says the integral of u dv, which is what we're looking for, is equal to u times v. So I have ln of x times negative 1 over x minus the integral of v du. Negative 1 over x times 1 over x. Minus minus, we can make plus. And now notice this is something we can integrate and finish the problem. So we have negative ln of x over x. This is the same thing as x to the negative second, and we can use the power rule. Let's try another one. The integral of x times e to the x squared. Even before you start with I late and try to decide what you're going to make u and what you're going to make dv and jump right into it, you always want to start by the techniques you've already learned. If you can u substitute, which in this case we can, this problem is much, much easier, even if it can be done by parts. I'm not sure if this one can or not, but notice if you make u equal to x squared, du is 2x dx. We need a 2. There's 2x dx. And a 1/2. My circled stuff becomes du. So we have e to the u. The integral of e to the u du is e to the u plus c. So we get 1/2 e to the u, which is x squared, plus c. So if it can be done by substitution, or one of the methods you've already learned, you want to do it that way. The integral of x times sine x. X times sine x. So no way to simplify that. It can't be integrated as is. I can't use substitute. Making u equal to sine x isn't going to help because I don't have a cosine x to make my du. It cannot be done any way you had learned prior to today. So we are going to do it by parts. I late. We have a trig function and we have an algebraic function. The algebraic function takes priority, therefore u is equal to x and my dv is equal to sine x dx. Derivative of x is 1 dx. The integral of sine x is negative cosine x. And the rule is u times v, x times negative sine x, minus the integral of v du. Negative is going to change that to plus. And we can finish our integrating. Example 3 here asks for the integral of x squared times e to the x. X squared e to the x. We've got an algebraic function and an exponential function. Algebraic function is going to be u. Exponential function is dv. Derivative, integral. So we get u times v minus the integral of v du. The integral of 2x e to the x. Can't use substitute. We need to integrate by parts again. We get to integrate by parts again. So this one, once we've done it once, we get down, we still have an algebraic function and an exponential function, so we're going to have to do it a second time. So we're going to make u equal to 2x. Again, that's the algebraic part, takes priority over the exponential part. So I've got x squared e to the x minus uv minus the integral of v du. Forgot my dx right here. x squared e to the x, distribute, minus 2x e to the x, distribute, minus minus is going to become plus, and the integral of 2e to the x is 2e to the x. A lot of times you'll see an e to the x factored out of those. It's fine if you do, fine if you don't. This one here, just real quick, this is one you have already learned how to do. Notice it's algebraic and algebraic. We did one like this last year where we made u equal to x minus 3 and du is equal to dx. So I have u to the 5th, and this is one after we use substitute that we still have this extra x in here, but we can solve this for x and substitute it in. Distribute. And now it's something we can integrate. U is equal to x minus 3. So again, kind of a review problem there. One more type we're going to look at, and then one I want you to practice. Make sure we've got this down. Is this the one I wanted? Let's do this one. The integral of e to the x cosine x. This one turns out a little different. E to the x cosine x. So again, think through your ways of doing it last year. There's no way to integrate this or change it so that it can be integrated. Exponential and trig, so our trig functions are u. And our dv is e to the x dx. And derivative of cosine is negative sine. Integral of e to the x is e to the x. So first time through here, nothing different. U times v minus the integral of v du. We're down to something here where we need to do it by parts again. Trig function again is u before exponentials. Du is cosine x, and v is e to the x. So we've got this part plus u times v minus the integral of v du. And notice we're right back where we started. We have e to the x cosine x. So if we try to do it again, we're going to wind up right here again. That's going to go back and forth and back and forth. I'm going to rewrite this so it looks like how we originally had it, v times du. So the e to the x first. It doesn't matter there. All right, so hopefully you can see what the problem is here. If we continue to do this, we're just going to start getting the same things over and over again. So the way that we're going to take care of that, notice we started with this, and we've ended here. So we're going to say these things are equal to each other. This is what we started with. and we evaluated it, and we found that it's equal to this. Now this and this are the same thing. I can add this to both sides. So now I have e to the x cosine x plus e to the x sine x. We integrated in there, so we probably should put our plus c. And I've got, on this side, I've got 2 of these integrals. So if I'm trying to get this, all I need to do is divide by 2. So the integral of e to the x cosine x dx, which is what we're trying to find, is equal to e to the x cosine x plus e to the x sine x plus c all over 2. Or you could put all over 2 and then plus c at the end. They're both the same thing. All right, one more problem. This one is for you to practice. You will not have to work through it twice like we did on the last one. It is a definite integral though. So pause the video, try it on your own. Once you think you have it, start the video and I'll show you the solution. So this one asks for the definite integral from 0 to 2 of x e to the x, algebraic functions above exponentials. So my du is equal to dv, or dx. Integrating this gives me e to the x. So we've got u times v minus the integral of v du, 0 to 2. Don't worry about the bounds here until we have completely integrated everything. X e to the x minus the integral of e to the x is e to the x. And now we can evaluate from 0 to 2. So we've got 2e squared minus e squared minus. So plugging in 2. Plugging in 0 gives me 0 minus e to the 0. So I get 1e squared plus 1. Any questions that you're having here, reach out, let me know. I'll get back to you. Have a good one. Please.